Hello, welcome to the EPG Pathshala program in Linguistics. I am Pramod Pandey, Professor of Linguistics at Jawaharlal Nehru University. Today we will discuss the module entitled Metrical Theory of Word Stress 2. We have already been introduced to metrical theory of word stress in the last module. In this module, we will be concerned with looking at greater detail with the metrical theory of stress, and then its revision as a metrical theory of the grid-based structure of stress, and we will also be concerned with some of the basic essentials of metrical theory. So the topics that we'll cover are essentially types of stress, mainly bounded stress systems, unbounded stress systems, and some basic concepts such as extrametricality. And then we'll move on to discuss the details of metrical grid theory of stress. Now, we have looked at the different parameters of word stress in the last module, such as quantity sensitive, quantity insensitive, left dominant, right dominant, bounded, unbounded, etc. So we need not talk about them at this stage, but let's look at some of the examples of the various stress systems that exist in the world. Now, let's begin with the quantity sensitive, quantity insensitive, left dominant system. Now, there are systems, and we have an example coming here, where within a system, there are different directionalities, that is from right to left or from left to right, in giving us different stress patterns. A language that exemplifies these two ways of forming stress, primary stress and secondary stress, is Garawa. Look at the examples on the screen. You have these words Jami, Punjala, Wachimpangu, Kamalarinji, Jakalakalampa, and Ngangkiri Kirimpaji. In all these words, you will notice that the initial syllable has primary stress, and then there are alternate syllables which are secondary, which have secondary stress. The directionality of them is different. You will notice this in the odd numbered words, such as Kamalarinji, for example, that the stress, primary stress is from left to right, and then the secondary stress is from right to left. In between, we have a syllable, we have a single syllable. Now, this cannot form a stress. That's how it is only in the odd numbered words that we find it is easy to see that there are two directionalities in the realization of word stress in Garawa. Now, the rules of word stress, these also are given on your screen. I will read them out. Primary stress, quantity insensitive, left dominant, fruit from right to left to right. So we can also say like this: raise, quantity insensitive, left dominant, foot from left to right. The rule for secondary stress: raise, quantity insensitive, left dominant, foot from right to left. And a degenerate foot is not allowed. That's how feet are formed. Then among the feet, 2 feet or 3 feet, finally we have one of them selected as the for word stress placement. And so the word stress is left dominant tree. That means of all the feet that are found in the language, it is the leftmost one that is that has primary stress. Now, let's look at the different types of stress systems. We have looked at the bounded stress systems: quantity insensitive, left dominant, quantity insensitive, right dominant. And now, there are also other bounded systems, such as quantity sensitive, left dominant, quantity sensitive, right dominant. Now, when we try and combine all of these, we get a typology as the one given here. For example, in A, depending on the two types of directionality, like left to right and right to left, we get these 4 plus 4 types of stress systems. Quantity insensitive left dominant and left to right, quantity insensitive left dominant, right to left, etc., as you see on the screen. Now, all these 8 types of systems are those in which we have regular feet. But there are also systems where degenerate feet are allowed. So of all these 8, we also have systems where degenerate feet are allowed. That means we now have 16 bounded type of stress systems in the world. Let's look at some of the examples on the screen. You have these 4 types on the screen: quantity insensitive left dominant, A; quantity insensitive right dominant, B; quantity sensitive left dominant, C; and quantity sensitive right dominant, D, as you can see. So in all these, when we say left dominant, right dominant, you can look at the labels SW. A syllable which has S is a dominant syllable. A syllable that has W is a weak syllable. And that's how we decide whether a system is left dominant or right dominant. Now, there are also, as we know, unbounded stress systems. We have already talked about this parametric variation. That is, unbounded stress systems are those in which there is only one stress system. There are languages like that, where we have either the leftmost syllable which is stressed or the rightmost syllable is stressed. Sometimes there are also the leftmost but one or the rightmost but one. These are called pen initial or pen final. So we have these systems, but the number of foot is 1. And that's how they are called unbounded stress systems. Look at the structure on the screen. One of them is left bounded with the S going on the left, and the other one is the right bounded with the S going on the right. Notice that it is the S, it is the branch labeled S that is also branching. So one of the properties of a W that is weak label is that it is non-branching. Now, so these give us different types of stress systems. We have bounded stress systems. We saw 8 plus 8, 16. We have unbounded stress systems of different types. It's interesting to note that world languages are not restricted to be only one of these. There are also other possibilities, depending on the use of certain devices in them. One crucial device that is found to be used in metrical stress systems is known as extrametricality. What is extrametricality? A constituent such as a syllable, mora, vowel, or consonant, when peripheral, that is, when it occurs at the beginning or the end of the word, can be ignored in building the metrical tree. So one of these, either the final ones or the initial ones, these can be entities such as a vowel or a consonant or both, called segment, or a mora or a syllable. Each of these are not somehow counted in raising trees. We then say that these entities, these units, are extrametrical. Let's take a look at an example from Malayalam. In Malayalam, a syllable with a long vowel, which is heavy, is stressed going from the right. Notice that only a long vowel is heavy in Malayalam. It's a heavy syllable. Because consonants always occur as the coda. So heaviness is not defined in terms of a coda. Coda is just not present in Malayalam. That's why we say a long vowel, which is heavy, that is the one which is stressed. Only on the condition that it's not final. So a long vowel in the final position is not stressed. But the first long vowel starting from the right and which is non-final is stressed. So we have these examples. Niyamam, in which there is no long vowel. So the first syllable is stressed because you couldn't find any long vowel. And then we have things such as Puranam, Malayali, Vasudevan. Now, in all these, as we see, Puranam, yes, that's the first heavy syllable. Malayali, the last li is a heavy syllable, but it's not stressed, going by the rule. And then Devan, De is the first heavy syllable, so it is stressed. Now the question is, why is it that a long vowel is heavy non-finally and is stressed non-finally? Why isn't it possible for Malayalam to have the final long vowel stressed? And the answer lies in the notion of extrametricality. That is, in Malayalam, the final consonant or vowel, C or V, that is the final segment, is extrametrical. So we call this final segment extrametricality. And these are shown on the screen, the way we represent the extrametricality. Take a look at the 4 words here. You will notice there's always the final, either the consonant or these two dots that columns which stand for length, that is for another vowel length. These are the ones which are marked extrametrical using angled brackets. That's the convention. If it's a syllable, then the syllable is enclosed in angled brackets. If it's a segment, then the segment is enclosed. Sometimes it may be a foot, with the entire foot is enclosed in angled brackets. We have examples of foot extrametricality in some of these Indo-Aryan Indic languages. We have some examples from Hindi on the screen. The rule for stress in Hindi is stress the first non-final heavy syllable. That's a long vowel or a VC, vowel consonant. Now these examples are given into these 3 groups. So we have Atithi, Bagula, Pipariya, Chabutara. The stress is always on the antepenultimate syllable. That is the 3rd from the right. In the second group, we have Sitara, heavy syllable, but not the final one, as in Malayalam, but the middle one. Kahani is the same. In the third one, we have 3 words, 3-syllable words. There also we notice that the generalization that the non-final first syllable, first heavy syllable from the right is stressed. If not, then the first leftmost syllable is stressed. That is, if there is a word without any heavy syllable, then it is the leftmost syllable which is stressed. And this is how, on the screen you see, that's how we represent the metrical tree structure of these words in Hindi. Now, so an addition to the description of stress in Hindi, there is another type of stress in Hindi that has been called super heavy syllables. A super heavy syllable. What is a super heavy syllable? A super heavy syllable is one in which we have a long vowel preceding a consonant. So a long vowel plus consonant, or a short vowel plus 2 consonants. Now Hindi is one of these languages, there are not many of them, which has an additional 3rd degree of syllable weight, namely super heavy syllables, in addition to light syllables and heavy syllables. Now why do we need super heavy syllables? Take a look at the examples given on the screen. We have Bima, which means insurance, and Bimar. Now the difference between Bima and Bimar is only the presence of a ra at the end. Similarly, Madad, 2-syllable, but Pasand. So the Pasand only has one more consonant in the last syllable. Now the difference is that Bima and Madad have stress on the first syllable, and Bimar and Pasand have stress on the second syllable. How do we explain this? The explanation that is offered is that the final segment or the final vowel or the syllable is treated as extrametrical. This has also been called final foot extrametricality. Somehow the final vowel or consonant is also treated as an independent foot. So that is extrametrical, and thus the first heavy syllable after that or the leftmost syllable is stressed. Now what happens to syllables that are marked extrametrical in the course of the derivation? Now it is assumed that if at a certain level, metrical level, a segment or a foot or a syllable is marked extrametrical, then it is considered to be stray at that level. However, it is incorporated as a metrically weak member of an adjacent constituent when we go up. So ultimately, the stray adjunction convention applies, and it incorporates the extrametrical syllable into the word as you see represented on the screen. So bima, ma is foot is extrametrical, and then stray adjunction applies, and you get bima with 2 feet. Left one is strong and the right one is weak. And we also pronounce them as bima. Nobody pronounces it bima. Now to metrical grid theory. The metrical stress theory of stress came to be revised as metrical grid theory, presented in detail in Bruce Hayes' 1995 book. Now it was proposed under the influence of many significant works, in the main Prince 1976, Hammond 1984, and Haller and Vernou 1987. The main aspects of the revision in the metrical grid theory from the metrical tree theory are discussed in what follows. First of all, in the metrical grid theory, one of the important constituents now that is added, that is available on a separate or independent level, is the bracketed grid. So the notion of bracketed grid is introduced here to stand for feet. And so what we notice is that we have the lowest level of syllable or mora. In the present module, we are using the syllable. The next higher level is that of the foot. So the foot is shown in brackets. The number of syllables that form a certain foot are enclosed at the foot level. And then we have the word level. So after the consonant vowel representations, these are known also as melodic representations. We have the next higher level, syllabic or moraic representation. Then we have foot representation, and then finally the word level representation. Notice that the word level gives us the primary stress. The foot level gives us the stresses. So if there are 3 stresses, there will be 3 feet. 2 stresses, 2 feet. And then at the word level, we know which one of them has the primary stress, is the most dominant one. So this is essentially the metrical grid theory. That is, you have different levels or grids for different constituents of metrical phonology. Now, the second important point about the revision in metrical grid theory is that in metrical tree theory, when it came to right dominant and left dominant and syllabic and moraic structures, we had 4 types of feet, namely syllabic trochee, that is a bounded foot quantity insensitive left dominant; moraic trochee, this is in quantity sensitive; then syllabic iamb, which is bounded foot quantity insensitive; and moraic iamb, bounded foot quantity sensitive. So the significance of the term moraic and syllabic is that syllabic systems do not take into account the weight of the syllable. Rather, they are blind to the weight, so they just go by the number of syllables. 2 syllables, the left one is stressed if it is trochaic, the right one is stressed if it is iambic. So dada will be trochaic, dada will be iambic, and that's the way words. Suppose you have a 6-syllable word, the syllables will go like this: right dominant syllabic quantity that is insensitive will be da-da, da-da, da-da. If it is syllabic and then quantity insensitive, that is, and left dominant, it will be da-da, da-da, da-da. Stress systems are like that. And similarly, we have moraic systems also, which have similarly, if you have 2 morae, long vowel or 2 short vowels, then these also are stressed either on the right short vowel or on the left short vowel. Now it so happens that on a good survey of many of these languages, they are above 300, Hayes came to the conclusion that it's difficult, there is actually no. So the revision, in the second revision rather, in the metrical grid theory is that in place of these 4 types of systems, we have actually only 3 types, namely syllabic trochee, moraic trochee, and iamb. Iambs are all syllabic. We do not have instances of iambic rhythm, which is moraic, that is quantity sensitive system. The tree structures of these various types of systems are shown to you on the screen. So we have this syllabic trochee, moraic trochee, and iamb. What are the uses of grid-based theory? In the grid-based theory, what we find easy to explain are notions such as stress clash and stress clash resolution and stress lapse. Sometimes we notice that the regular stress pattern in language changes when there is word formation or when there are words coming into in a compound word, etc., or within a phrase. Now the phenomenon of stress clash is explained thus. That is, if there are 2 stresses at a given level, grid, if those 2 stresses also are there present at the lower grid, then we have instances of stress clash. Now it so happens that in world languages, this is not liked. Stress systems do not like stress clash. So what happens? Different languages resolve this issue differently. In some languages, one of the stresses may be deleted. In another language, the stress placement, the place of the stress may be shifted. Thus, we have examples on the screen of English, these words, Cornell, hockey. There are 2 words, Cornell and hockey. When they come together, then we hear these words pronounced as Cornell hockey. It's a well-known example in the literature. Now, so which means the stress on the independent word Cornell shifts to Cornell because of stress clash. The following word also begins with a stress. So instead of Cornell hockey, we hear Cornell hockey. What has happened here? The stress in the left word has shifted 1 notch on the left. In addition to stress clash, we also have the phenomenon of stress lapse. What is stress lapse? Stress lapse is the opposite of stress clash. So the normal tendency in languages is to have the rhythm of stress, unstress, stress, unstress, or unstress, stress, unstress, stress. So alternating rhythm. If there is a sequence of unstressed syllables, let's say, as it happens in unbounded systems like Malayalam, for example. So all short vowels, a 5-syllable word, the leftmost syllable is stressed, and then we have 4 syllables which have no stress. Now this is an example of stress lapse, because we have a sequence of syllables where the alternating rhythm is missing. What happens in these systems is that there is alternating stress which is placed in addition to the primary stress, and all of them are realized as secondary stresses. We have the examples from Malayalam on the screen. So Malayalam, Ilamnir, etc. You notice that whenever there is a sequence of more than one syllable which is unstressed in Malayalam, you tend to stress it. It also has an effect on the vowel. A vowel such as when it is stressed is a, something like shut in English. Now that the presence of is an indication, is evidence of a secondary stress being present in Malayalam. Now, so I hope you are able to do the exercises on metrical grid theory. It is this theory which is now being in use, but of course metrical tree theory is as much a part of the literature, and you should be familiar with either of them. I suggest that you go to the recommended books and do the exercises to support your understanding of the notions and terms used in the module. Thank you.